Alright, go ahead and get your popcorn out and ready and whatever snacks you have. This one might take a minute. From lecture 36, this is kind of a continuation about circles and tangent lines. So let's look at an example here. We have an equation of a circle in green. One thing I like to point out or identify is a center, okay, which is my H and K. My H in the equation is positive 1. Remember, if I'm going to figure out the x coordinate of that, that'd be negative 1. Just the opposite. I have no K, which that is okay. So my center is negative 1, 0. Now this point out here is a point on the circle. Yeah, you could actually plug this in for x and this in for y, and it will be a point on the circle. It would actually equal 50 if I plugged it all in, which I'm not going to, just for time's sake. Now the reason I identified the center of the circle was, we're trying to find a line that touches the circle at one point, a tangent line, through this point right here, 6, 1. Okay? Now, you want to identify the center so that we can figure out the slope of the radius. Okay, so let's pretend that this is the center of the circle here. And way over here is the point, 6, 1. Okay, I'll just go ahead and label it. Now, the reason I need to find the slope of that line, that radius, is because if you remember back in lecture 36, tangent lines have a slope that is perpendicular to the radius. So, if we had to write steps down, our first step is we need to find the slope. Okay? The next step is figure out the perpendicular slope. So I'm going to write perpendicular slope. I could have just wrote M, but okay. Anyway, some of us actually messed up slope here, so let's go back and review. X1, Y1, X2, Y2, no particular order. Slope of a line is M equals Y2 minus Y1. Guys, we've done this 1.5 billion times. Hey, what's one more, right? So, there's the formula I want to use, and I'm just going to plug and chug into that formula. I'm going to start saying substitute, because that's what it's really called. 1 minus 0 over 6 minus negative 1. Now, I'm just going to do some simple math. Work the top out. 1 minus 0 is 1. 6 minus negative 1 is 7. So here's my first step. I found a slope. Now, what I need to do, since I have the slope, 1 over 7, make sure I'm right, I need to find a perpendicular slope. Well, what's the opposite of positive? Negative. And then flip the fraction, 7 over 1. Now guys, this is going to start looking familiar because, we have a point, and I'm going to emphasize this point again. Our line touches that point on the circle. And it goes back to using things, concepts that we've already talked about. So I know it's got to pass through 6, 1. It touches 6, 1. Okay? And now I have that slope, the perpendicular slope. Remember, a tangent line is a perpendicular line to the radius, which we found. Now, all I'm going to do is, we're trying to write an equation of a tangent line. Let's use slope-intercept form. I'm going to rewrite 6, 1, because that was the point that it touches. I'm going to label it, okay? I'll go ahead and plug in -7 over 1 in for m. I'm going to plug in 1 in for y, and let's go ahead and plug in 6 in for x, plus b. Now, if you remember finding parallel and perpendicular lines, we need to find the slope first, and then we can use that information to help find a y-intercept, a b. Alright, so 1 equals -42, because it is what it is, plus b. Alright, solve the equation, get b by itself. I'm going to add 42 to both sides. So b equals 43. Now, I found a perpendicular slope to my radius. Check. I found my y-intercept. Check. What can I do with that now? Well, write your equation of the tangent line. Y equals -7 over 1 x, and then I got my b, which is 43. So I'm going to write plus 43. So guys, you're really using what we've done before, okay? Identify the center, and then find the slope between your center and your point. That's the first step. Second step is we need to make this slope, or take this slope, and find the perpendicular slope, which we did, okay? Which we have right here. Now I'm going to take the point that the tangent line touches and my slope and plug into slope-intercept form of a line. Well, we did that. We found what? A b. Once you have your perpendicular slope and that y-intercept, you can make your equation for the tangent line. Alright? You may have to watch this again. Maybe it'll sink in. But guys, it's stuff that we've already done before. So, it's going to take a minute, but hopefully you guys will be okay with it. I'll see you tomorrow.